Hello, our final fluids project is a Torricelli lab demonstration.
We can derive the theoretical velocity using Bernoulli's principle, which relates initial and final velocity, height, and pressure. The initial velocity is 0, and the initial and final pressures are both atmospheric pressure. We can subtract rho gh from both sides to simplify the equation. We can factor out rho g on the left side, and h minus h2 will just be h, the height above the hole. We can now simplify for v as a function of h.
Based on the equation we derived, when we're trying to graph a v versus root h graph, the slope should be equal to root 2g. So we want to show that the experimental data we get versus root h graph should also have a slope close to root 2g.
Here are the materials we used to conduct this experiment. And for our experiment, we simply created a hole in our water bottle and determined the height and the distance that the water fell out of the hole. And we sped this out 5 times for the sake of time.
Now what? How do we find the velocity of the water leaving the bottle? We can do this by using the kinematic equations for the vertical and horizontal directions of motion. Using the kinematics for the vertical direction of motion, we can derive an expression for the time it takes for water to enter and leave the hole. Now using the kinematics for the horizontal direction of motion, we can derive an expression for the velocity of water leaving the tube, leaving the bottle as an expression of delta x.
Okay, so delta y will always be negative 0.08 meters, and you can graph the height above the hole to the horizontal distance displaced. And you can cross-check this with the regression model on Desmos.
This error is pretty small and may be due to human measurement inaccuracy. However, this confirms that our experimental and our theoretical results match up.